Now let's just talk about the next question, that is question number 4, which says that ABCD is a parallelogram and AP and CQ are perpendicular from the vertices A and C. So this is the actual figure on the diagonal BD. We have to show that APB triangle is actually congruent to CQD triangle, and furthermore we have to show that AP is nothing but is equal to CQ. So let's just start the proof of the very first part. First of all, let us suppose if I'm just giving the name to this particular angle as nothing but angle 1. Let us suppose if I'm taking it as angle 1, and if I'm taking this as nothing but the angle 2. Let us suppose if I'm just taking it as angle 1 and angle 2. So what can we say about the angle 1 and angle 2? Since first of all we know that since ABCD is a parallelogram, since it is a parallelogram, and BD is a transversal, between the parallels AB and parallel to, it is nothing but parallel to CD, then angle 1 should definitely is equal to the angle 2. Why so? Because they are forming up a pair of alternate interior angles. So they are alternate interior angles, that's why they are equal to each other. Furthermore, let us suppose if I am just talking about the two triangle. In triangle APB and triangle CQD, we can say that first of all angle 1 is equal to angle 2. It is already proven above. It is already proven case, and furthermore we can see over here that APB is actually nothing but is equal to the angle CQD. Why so? Because each is 90 degree. You can see over here, this is nothing but a 90 degree angle, this is nothing but a 90 degree angle. So hence each is 90 degree, that's why they are equal to each other. Furthermore, we can say that AB is actually is equal to CD. Since ABCD is a parallelogram, so its opposite sides are actually equal. Since ABCD is a parallelogram, so its opposite sides are actually is equal to each other. So it implies that the triangle APB is actually congruent to the triangle CQD by a congruency. Which one? You can see over here that this is nothing but the angle, this is nothing but the side, and this is nothing but the angle. So by angle side congruency means by AAS congruence criteria, we can say that they are congruent to each other. So this is the end of our first part. Now what can we say about AP is equal to CB? Obviously we know that the triangle APB is congruent to the triangle CQD. So it implies that AP is nothing but is equal to CQ by CPCD. So by CPCD we can say that the AP height is actually nothing but is equal to CQ. So this is all about the question number 4.